There are places on Earth where survival isn't just unlikely, it's impossible. One where the air acts like a chemical weapon, another so cold your skin goes numb before your brain can register fear. And later in this video, we'll reach a place that looks harmless until you realize the most lethal thing is invisible. These aren't myths, they're real places where survival isn't just hard, it's mathematically, biologically, and physically impossible. Our first stop doesn't look like Earth. It looks like a Mars fever dream. Neon yellows, oranges, greens, and air that poisons you faster than you can escape. Welcome to the Danakil Depression, one of the lowest and hottest regions on the planet. Burning salt flats, volcanic rock, and sulfur under a sky that seems to shimmer. The ground becomes a psychedelic canvas, beautiful, unreal, and that beauty is a trap. The colors come from violence, minerals precipitating out of super salty, super acidic fluids as the Earth cooks itself from below. Here's what makes it worse. This is not random. The depression sits where 3 tectonic plates are pulling apart, Africa literally tearing at the seams, feeding constant volcanic and hydrothermal activity. Temperatures here can climb past 122 degrees Fahrenheit, 50 degrees Celsius, turning the air into a furnace that evaporates sweat before it can cool you. And the water here? Don't call it that. The ground bubbles with hydrothermal springs, pools of superheated acidic brine, throwing toxic vapors into the air. In the Dalal geothermal area, researchers have measured extremely acidic conditions, around pH approximately 0, with hot spring temperatures reaching roughly 90 to 109 degrees Celsius. It's so alien that astrobiologists study it as a window into what life might look like on other worlds. Now, here's the twist. Even when there's liquid water, life can still lose. Studies of the most extreme pools in the Danakil/Dalal system have found sites showing no detectable DNA signal above background and no recoverable 16S amplicons, essentially sterile pockets despite the water. So what happens if you step into this unprotected? It's swift and it's brutal. First comes aggressive hyperthermia. Your internal temperature climbs as your cooling systems fail. Then every breath becomes damage. Vapors burning the respiratory tract. Your skin blisters, not only from heat, but from chemistry. Dehydration accelerates so fast, your kidneys can begin to shut down within hours. Consciousness fades. Then you simply collapse, silent, on a landscape that looks like a painting and behaves like acid. And yet, humans are still here, at the margins. The nomadic Afar people have lived on the edges of this region for centuries, reading its danger like a language, mining salt in conditions most people can't imagine. For outsiders, scientists, film crews, visits are short, controlled, and often require protective gear just to approach the most active zones. The Danakil is proof that Earth still contains places as alien as anything in space. But if heat can kill you, we go to a place that holds the coldest official air temperature ever measured. We're heading deep onto the East Antarctic plateau, to the area around Vostok Station. On July 21st, 1983, instruments at Vostok recorded minus 89.2 degrees Celsius, minus 128.6 degrees Fahrenheit. That's the lowest directly observed surface air temperature on Earth. And that number is more than trivia. It's a warning. Why is this place so cold? It's a perfect trap. High elevation, over 11,000 feet above sea level, thin, dry air, an inland position, far from any ocean that could soften the climate, months of polar night where the sun doesn't rise at all, and then the katabatic winds, dense gravity-driven air draining off the plateau, stripping away warmth like it's dust, and it can get worse. Satellite analyses of the East Antarctic Plateau have found ice surface temperatures plunging to around minus 98 degrees Celsius, minus 144 degrees Fahrenheit, in small depressions under the right conditions, colder than the Vostok air temperature record, but measured at the surface by remote sensing. So, what happens to a human body here? Exposed skin frostbites almost instantly. Water in cells begins freezing, forming crystals that shred tissue. Blood rushes to the core to save organs, leaving fingers, toes, nose, ears to freeze first, like they're being erased from the outside in. Then hypothermia hits like a switch. Core temperature drops. You shiver violently. Your last emergency program. And then the shivering stops. That's the moment the body is losing. Blood thickens. The heart strains. Inhaling air this cold can injure lung tissue. Confusion turns into delirium. Delirium into coma. Then heart failure. Survival here isn't toughness. It's technology. Scientists at Vostok live in insulated, heated modules. Even stepping outside for moments demands specialized layers and face coverings that warm the air before it hits the lungs. Antarctica is mostly uninhabited, but places like Vostok are its frozen center, a region so cold it doesn't merely threaten life, it cancels it. And after cold like that, you'd think heat would feel familiar. It won't. Now we pivot back to heat, because the planet's hottest places don't just burn, they overload the human system. Most people think of Death Valley, California. It's a sun-baked bowl that can feel like standing in front of an open oven. It officially holds the record for the highest air temperature recorded in Death Valley, 134 degrees Fahrenheit, 56.7 degrees Celsius, at Furnace Creek on July 10, 1913. But there's controversy. Some weather historians and modern experts have questioned the reliability of certain early 20th century readings. The World Meteorological Organization still recognizes the 1913 value as the official record unless new, credible evidence overturns it. Either way, Death Valley is lethal now. Temperatures have also reached 54.4 degrees Celsius, 130 degrees Fahrenheit, in recent extreme events, readings that have been under formal review/verification by the WMO. And this is why it happens. Much of the valley sits below sea level, boxed in by mountain ranges. Hot air pools, trapped and baked like an oven that never opens. But even Death Valley has competition, because air temperature is only half the story. Land surface temperature is the literal heat of soil and rock. And in Iran's Dasht-e Lut, satellites have recorded extreme land skin temperatures. NASA Earth Observatory reported a MODIS measurement of 70.7 degrees Celsius, 159.3 degrees Fahrenheit in 2005. And NASA MODIS analyses have also reported peaks as high as 80.8 degrees Celsius, 177.4 degrees Fahrenheit in later years. That's not hot, that's sterilizing. It happens because parts of the Lut are covered in dark, heat-absorbing surfaces, and the geography can trap superheated air close to the ground. So what does that do to a human body? Heat stroke, fast. Your body tries to cool itself by sweating, but in superheated, dry air, sweat evaporates instantly, and your cooling system collapses. Core temperature spikes. The nervous system glitches. Confusion, delirium. Skin goes hot and dry as sweat glands fail. The brain can swell. Seizures can follow. Then the heart gives up. And the danger isn't theoretical. Tourists in Death Valley underestimate it every year. A simple vehicle breakdown can turn into a death sentence. Park staff will even close roads in extreme heat because they know how quickly a minor problem becomes fatal. The Lut is worse for a different reason. Remoteness. No settlements, no water, no shade. Just a vast anvil under the sun, where the ground itself can reach temperatures humans were never designed to be near. But heat isn't the only way the planet kills. Sometimes it just removes one ingredient and lets your body do the rest. Our next stop isn't defined by extreme heat or extreme cold. It's defined by absence. Water. We're heading to Chile's Atacama Desert, one of the driest non-polar deserts on Earth. In its hyper-arid core, average precipitation can be under 2 millimeters per year. The landscape is so Mars-like that NASA has used parts of the Atacama to test life detection and rover technologies for Mars missions. The dryness is hard to comprehend. Some locations appear in historical and geological records as going centuries without significant rainfall, often described as 400+ years in the most extreme pockets. So rain becomes an event measured in generations. And it's not bad luck, it's geography. The Atacama sits in a double rain shadow. The Andes block moisture from the east, and cold upwelling along the Pacific coast helps suppress rainfall and clouds. So what happens if you're stranded here? It's slow, and it's terrifying. The air pulls moisture from you with every breath. Lips crack and bleed. Eyes feel filled with grit. Blood thickens as fluid is lost. Pressure drops. The heart strains. Delirium and hallucination arrive as the brain dehydrates. Days later, organs fail, and the desert does something bleakly efficient. It preserves what's left. But the Atacama has an even stranger cruelty. In 2015 and 2017, unusual rain events created temporary hypersaline lagoons, and researchers found those sudden floods caused a massive die-off in local microbial communities, driven by osmotic stress. In other words, water arrived, and it killed life. That's the kind of place this is. Even the thing that defines life can become the weapon. Yes, there are towns on the fringes, but the core of the Atacama remains one of the most lifeless landscapes on Earth. And now we move from lifelessness you can see Our next stop is the Chernobyl exclusion zone in Ukraine, created after the 26th of April 1986 disaster at Reactor 4, an explosion and fire that released large amounts of radioactive material into the atmosphere. A 30-kilometer exclusion zone was established around the plant, and the restricted area in Ukraine is roughly 2,600 square kilometers, about 1,000 square miles, where access and habitation are controlled. Entire communities were evacuated, most famously the nearby city of Pripyat, cleared on April 27, 1986. An eerie reminder of what happens when humans leave. But don't confuse greenery with safety. The landscape is contaminated with radionuclides, including cesium-137. You can't see it, smell it, feel it. But in hotspots, a Geiger counter will scream, a frantic clicking that translates to one message: get out. So what happens to a person exposed to high doses? The name is clinical. The reality isn't: acute radiation syndrome. In a significant exposure, nausea and vomiting can begin within hours. Then comes a cruel phase where you might feel better, the latent period, while radiation is still destroying dividing cells inside you. Bone marrow fails, the immune system collapses, the gastrointestinal lining breaks down, bleeding begins, hair falls out, and at extreme doses, the central nervous system can be hit. Confusion, seizures, collapse. The first responders at Chernobyl proved how fast this can happen. Firefighters who fought the initial blaze received massive doses. Accounts describe victims being buried in sealed coffins, often portrayed as lead-lined, though many sources describe zinc enclosures and additional barriers to reduce the spread of contamination. Today, the zone remains heavily restricted, with controlled access in designated areas for work and limited tourism, often with visitors carrying dosimeters to track cumulative exposure. And in the most contaminated places, some radionuclides will remain a hazard for decades to centuries. And yet, the most terrifying part is this: radiation turns a normal-looking place into a trap you can't sense until it's too late. We're descending into the Mariana Trench in the western Pacific Ocean, the deepest part of Earth's oceans. Its deepest known point, the Challenger Deep, lies around 11,000 meters below sea level, nearly 36,000 feet down. Down there, it's eternal darkness. Water temperatures hover near freezing, and the pressure isn't high, it's obscene. For roughly every 10 meters you descend, pressure increases by about 1 atmosphere. At approximately 11,000 meters, you're looking at over 1,000 atmospheres of pressure, well over 1,000 times sea level air pressure. That's often compared to having around 50 jumbo jets stacked on top of you. So what happens if a human body is exposed? Instant failure. Not crushed like a cartoon, imploded. Any airspace, lungs, sinuses, inner ear collapses catastrophically. The body can't resist that force. The timeline is fractions of a second. No time for panic, no time for pain, just instant obliteration. And the trench itself is hostile in another way. It's a world without sunlight. Yet life exists here. Bizarre life, like the Mariana snailfish, a soft-bodied fish found living at Hadal depths, approaching 8,000 meters. There are also hydrothermal vents, where seawater circulates through hot rock and can erupt back out at temperatures above 400 degrees Celsius, 750 degrees Fahrenheit. Superheated fluid in a freezing, lightless world. Human exploration has been rare because it has to be. For decades, only a tiny number of people had ever visited Challenger Deep. More recent expeditions have increased that number, but it remains an exclusive list measured in dozens, not hundreds. Each time, the traveler is sealed inside a pressure sphere, often titanium, because outside is instant annihilation. And in a strange way, it's more remote than the moon. We've sent thousands of people into the sky, but only a few dozen to this depth. And after the brute force of the deep ocean, we return to land for a different kind of uninhabitable, one we built ourselves. Not all uninhabitable places are nature's doing. Some are engineered. High in the Peruvian Andes lies La Oroya, home to a metallurgical complex established in 1922. For decades, especially before modern controls, smelting operations ran with weak oversight, releasing a cocktail of heavy metals, including lead and arsenic, into the air, the soil, and the water. It has been cited for years as one of the most polluted inhabited places on Earth. The danger here isn't sudden like Mariana pressure. It's slow, creeping, stealing years instead of seconds. The air has carried sulfur dioxide, contributing to acid rain and stripping surrounding hillsides. But the most insidious threat is lead, embedded in dust and soil, especially deadly for children. And that's not exaggeration. Investigations have reported that around 99% of tested children had dangerously high blood lead levels at certain points in the town's history. Lead poisoning hits developing brains first, lowered IQ, learning disabilities, behavioral problems. Long-term exposure links to nerve damage, respiratory illness, and other serious health outcomes. And it doesn't always start after birth. Studies in La Arroya have reported elevated lead levels in pregnant women and measurable lead in umbilical cord blood in newborns, meaning exposure can be passed on before a child even takes their first breath. This is what makes La Arroya uniquely tragic. It's an uninhabitable place that is still inhabited. Around 30,000 people live here, many with livelihoods tied to the very industry that poisoned the air. And in a landmark ruling publicized in 2024, the Inter-American Court of Human Rights held Peru responsible for violating residents' rights, ordering measures including care and remediation. Justice on paper doesn't erase contamination in the ground. The legacy is still there, an uninhabitable environment created not by geology, but by negligence. Now, for our second to last stop, we return to Antarctica, because there's a place there that isn't icy. It's simply erased. Antarctica usually means endless ice. The McMurdo Dry Valleys break that image. These are largely snow-free valleys, nearly 2,000 square miles, approximately 4,800 square kilometers of barren rock and frozen soil, one of the largest ice-free regions on the continent. They're often described as the coldest and driest desert on Earth, and the reason is wind. Katabatic winds, dense air draining down from the polar plateau, can scour the valleys, evaporating and sublimating snow before it can settle. And Antarctica's katabatic winds can reach extraordinary speeds, often described as up to around 200 miles per hour, about 320 kilometers per hour in extreme cases. But even without the wind, the climate is vicious. Peer-reviewed climate analyses put mean annual valley floor temperatures roughly between minus 15 degrees Celsius and minus 30 degrees Celsius. Now imagine being exposed here. Wind chill turns cold into injury, making something like minus 20 degrees. Fahrenheit feel closer to minus 90 degrees Fahrenheit in exposed gusts. Hypothermia accelerates. The air is so dry it strips moisture from your lungs with every breath. And the wind can drive ice and dust like sandpaper against skin. Frozen, flayed, desiccated, all at once. There are no plants, no animals. Life exists, but barely. Microbes survive by hiding inside rocks. And NASA has used the dry valleys as a major Mars analog environment, even for mission-related studies. Research teams here live in fortified camps because the environment isn't bad weather, it's an eraser. Our final destination is a paradox you can see from the sky, a shallow lake in northern Tanzania that often glows crimson red. Lake Natron. It's a soda lake, rich in dissolved sodium and carbonate. Volcanic geology feeds mineral-rich inflows, and high evaporation concentrates them. The result is water that can reach around pH 10.5, almost as caustic as ammonia, and temperatures that can climb to about 60 degrees Celsius, 140 degrees Fahrenheit. So what happens if a human falls in? Chemical burns, immediately, eyes and skin hit by high alkalinity. Heat amplifies the damage, and while the internet loves to say this lake turns animals into stone, the real mechanism is even creepier. Deposits of sodium carbonate can preserve dead animals and encrust them, creating calcified, mummy-like remains that look petrified. The same chemistry that makes the lake hostile also gives it its color. Salt-loving microorganisms thrive here, tinting the water red. And then comes the most mind-bending part. Despite being a chemical death trap, Lake Natron is one of the most critical breeding sites on Earth for the lesser flamingo. Research has described Natron as the main global breeding site, with estimates that around 75% of the world's lesser flamingos are born here. The birds have adapted, tough legs, nesting on salt islands, and a hostile moat that keeps most predators away. The lake that kills most creatures becomes, for flamingos, a fortress. And that is the pattern you should remember from every place in this video. Earth is not safe by default. We survive on a thin band of conditions, and when those conditions snap, the planet doesn't negotiate. These places aren't just geography. They're proof that the world still has corners where the rules are different, and the human body is not invited. If you found this journey into the planet's most extreme pockets fascinating, subscribe and hit like, and tell me in the comments, which of these places felt the most terrifying, and why? Because here's the quiet truth behind every lethal location we visited. We are creatures of balance, adapted to a narrow window of pressure, chemistry, temperature, and water. When that balance breaks, resilience becomes meaningless. And that's what makes these places so haunting. They aren't monsters, they're mirrors, reflecting just how fragile habitable really is.